Functions. Hello everyone, Ben Finkel here, and in this nugget, we're going to take a look at the role that functions play inside of the Python programming language. Now, functions are a really cool logical construct that a lot of programming languages offer. And they basically allow you to write a piece of code, set it aside, and then execute it on demand as many times as you'd like throughout the lifetime of your program. In this nugget, we're going to take a look at how we can call functions. That's the most basic thing that you do, which is simply the way that you call the function you tell it to execute. Then we'll take a look at how we define our own functions, and we can write as many functions as we want. We can have them do whatever we'd like to, so it's really powerful. It's really important to learn how to do that. And then lastly, we'll take a look at how we can import functions from external files, return values from those functions, and we'll talk about a really important concept, variable scope. All right, there's a lot to cover in this nugget. Let's get going. Python is a procedural programming language, and this is a pretty common type of programming language, largely because it's easy for us as developers, as programmers, to follow along and understand. And what we mean by that is when you look at a little piece of Python code, it's going to execute each line from top to bottom in order, 1, 2, 3, 4, and the lines are generally read left to right, just like you read a book of text in at least Western languages. So it makes sense. Everything's executed in order. Every statement executes first before the next statement is evaluated and executed, right on down the line. That's how the program is interpreted. That's how you present the instructions to the computer. Well, as we've already talked about in some earlier nuggets, this isn't always ideal. Sometimes we want to do some other fancy manipulation that isn't just straight top to bottom, left to right. So we talked about conditionals, and conditionals allow you to skip over some pieces of code depending on the different state of the variables inside of your program. And we've talked about loops, which allow you to repetitively repeat pieces of code over and over and over depending on, again, the state of the variables inside of your program. So you can make some nice, dynamic, flexible executing programs with a few simple constructs that change up, that mix up that procedural dynamic a little bit. Well, another very basic type of way that we can do this is with something called a function. And a function, if you worked at math at all, is the same thing as a math function. What we're going to do is we're going to take a little bit of code, a little bit of math, a little bit of whatever, and we're going to bundle it up into a separate piece, set it aside, and then use it whenever we'd like. And, you know, we've been using functions a whole lot already. I often say that writing programs is a lot like cooking. These are two very similar things. And in cooking, the first thing you need to do is get a hold of your ingredients and kind of set them out, lay them out, right? Any good chef knows that the first thing you want to do is figure out all the ingredients for your recipe, measure them out, set them down, and put them aside. Mise en place is the fancy phrase that the chefs like to do for this. And in programming, you want to do the same thing. You're looking at this big, complex program, these instructions that you need to hand down at the computer. Well, a good thing to do is to break it down into individual components, set those aside, and write them as functions. So some of the functions that we've already seen are the built-in functions, right? There's a lot of those inside of Python. And you can add in libraries, you can import third-party libraries that add a whole bunch more functions. But one of those built-in functions we've used a whole lot is print. And we didn't have to do anything to use print, right? You could open up the Python command line interpreter, you could type print, open paren, put some text in there, close paren, and that would print right out on the screen. So it's built into Python, and that's a function. Because think about it, your computer doesn't actually know what print means. It doesn't know how to print a statement to the screen. It doesn't know what to do there. The instructions that the computer actually needs to do that are much more low level and they're much more complex. But because that's such a common task, it's something that we want to do so frequently, the people who made Python took all the code that accomplishes that, all the probably hundreds of lines of code that cause that information to appear inside of your screen, and they bundled it up, they made it nice and neat for you, and they set it aside and they gave it a name. They called it print. And every time you want to use that code, you reference the name print, you pass in the value that you want to be printed on the screen, and voila, that information is printed on the screen. That's called calling a function. In Python, when you call a function, you hand over control or processing of the program to the code that's inside of that function. So it's still procedural. You've just kind of stepped outside this main list, this main part of your program, and you've turned control temporarily over to this function. And when this function is finished, it's going to execute through top to bottom, left to right. It's still procedural programming. When it's finished, it's going to return control back to your program. So the important parts of calling a function here. First, you've got the function name, print, input, whatever the name of the function is. Then you've got the open parenthesis, and very important, at the end of the statement you have to have the close parenthesis. Now maybe that's all you have, but if you're going to pass any values into that function, they need to go here in between the parentheses, and they are comma separated values. So there might be 1, there might be 2, there might be 3. It all depends on the function, whether or not there's going to be 0 or 1 or 10 parameters supplied to that function. But they need to be inside of those parentheses, they need to be comma separated, and generally speaking those can be any type of value, any type of parameter or variable, that you want. Now one last thing happens when we call a function is that function returns a value. So we've seen this, say, in the input function when we've used input, right? Input, open paren, you put in some stuff, close paren, but then what we're doing is we're collecting information from the keyboard. So when that function is finished executing, it takes whatever was keyed in on the keyboard and it hands it back, and the program expects, Python expects there to be a variable defined on the left hand of an equal sign, an assignment operator, on that function. So let's take a look now at calling a couple of functions and really talk about what's happening in each function call. So here I've got a very simple, straightforward program. You can see it just does a few things, establishes some numbers, multiplies them together, prints it out. So let's talk about exactly what's going on here. So first, this is a procedural language. My code is executing top to bottom right on down the line. So I assign the value of 10 to x, and then I assign the value of 20 to y. Then I multiply x and y together, and I assign the result into the variable z. Now I make my first function call. I call the print statement. And notice what's going on here. I've got my function name, print, an open paren. I'm passing in one variable. I'm passing that variable. I'm sending that variable z to the print function. Now the print function itself knows what to do with that variable. So I don't have to worry about anything else. I just know that I'm passing that variable in between my parentheses to the print function. So what happens here is at this point in my program, it goes off to the print function, wherever that's defined, and actually you can see up here it's defined in my future library that I imported. And it does whatever it needs to do to cause the print function to work. And when it's done, it returns control back to my program right there at the next line, which if we take off my scribbles here is line number 9. Yeah, so that's what's going to happen. It's going to go off, it's going to print that, and then it's going to return control, and at that point it's going to continue on with the program. Now I've got another function. Here I'm calling the input function. And again, I've got a parameter in there. It's enter a multiple of 10. And notice I put it inside of quotes because it's a string. I have to define it as a string literal. But that doesn't change the fact that it's just a variable that's being passed into the program. In fact, I could do it like this. Let me show you. Here, instead of putting the text right inside of the input function, I assigned it to a variable called temp, and then I passed that variable temp into input. Same thing either way. This just creates another temporary variable that I'm going to use. You might want to do it this way. It might make your code a little bit easier to read. You can also, of course, make your code dynamic. You can have the message displayed actually be dynamic based on what's inside that variable. But either way, the same thing is going on. I've got my input, my function name, open paren, my parameter, and close paren. So code is going to get shuffled off to the input function, which is defined inside of the built-in Python library. It's going to do what it needs to do to read keystrokes from my keyboard. And in this case, I happen to know that the input function, when I press enter on my keyboard, it finishes and it returns control back to my program. But this time, I've got an equal sign. I've got the assignment operator and another variable, a variable called a, on the left-hand side of that equal sign. So when input is done executing, when it's finished doing what it needs to do, and it returns control, it's not going to go to 13 yet. A value is going to get sent back from the input function, and it's going to get put into my variable a. That's called a return value, or a result from our function. So I capture the value that the user keys into the keyboard, divide it by 10, and then lastly down here, I call one more function. I do this one more time, calling the print function, and notice that now I've got multiple parameters in my print function. I've actually got 3 parameters. So I print a, that's the first parameter that's sent to the print function, and then I have this little string divided by 10 is, and then I pass in b, that's the result of my math function. So print, again, knows how to handle just one parameter. It also knows how to handle 2 or 3 or 10. It can figure out, based on the number of parameters that you pass to it, what it needs to do. It can handle any number of parameters, and in this case, it's going to print all this off, as we've seen, concatenated together on the screen one after another. So real quick, let's just see it in action, although I think we can all imagine exactly how it's going to work. And there it is. 10 times 20 is 200. That is correct. Now it wants me to enter a multiple of 10. I will enter in 30. 30 divided by 10 is 3, and then it executes. So very simple, no problem. Calling functions, very easy. We do it all the time. There's also another little quirk of syntax that I'd like to show you, and this is common again in procedural languages, but if you're coming from something like JavaScript, this is a little different than how JavaScript works. Say I wanted to do print range of 10 comma a. So here I've done something really interesting. I've got two functions nested inside of each other. I'm actually passing a function in as the parameter to print. Well, how does it print a function? It doesn't know how to do that, and actually it doesn't. Here's the way this gets executed inside of Python. We can do this multiple times. We can nest things inside of the parameters as much as we want, but the lowest level function will get fully executed first. So the range function is going to go off and do its thing, and its return value is going to be passed into print as the parameter. And that's really, really important. I want to make sure you understand that. The function gets executed, it gets evaluated by the program, and the return value is what gets passed into the next function up. So when we see this run, 30, what's going to happen is the range of 10 to 30 is now getting printed out. That's the result from the range function. So I want to highlight that to show off the fact that, say, differently from JavaScript, the function itself is not passed into the print function. The result of the execution, the evaluation of the range function, is being passed into the print function. We call that parameters being passed by value. Write that down on a little post-it note. We're going to come back to it in a few minutes. That's really important for understanding functions, particularly when we start doing defining functions, as in defining our own functions. After all, Python doesn't already have a function to do everything we want to do. If it did, we'd never have to program anything. We just call a bunch of functions. So a big part of writing our own program is going to be defining our own functions. And we do that real easily. We simply say def, and then we give it a function name, and then an open paren, a list of parameters that we might or might not want, colon to finish off that statement, and then we'll have our entire function defined using the indentation, the block indentation syntax inside of Python. So what are we doing here? Well, here we're setting aside one of our ingredients. We're determining how much flour we need, we're measuring it out, and we're putting it aside in a little cup on our countertop so that it's ready to use when we want to use it. It's kind of like the looping function, right? We're taking a piece of code and we're going to use it multiple times over and over and over. We can call a function multiple times, of course. But the difference is, in a loop, we simply execute through it when our program reaches that part of the code, and it does it however many times it's supposed to do it, and then the program moves on. Here, we're almost kind of looping through it on demand. We're calling it as many times as we want, but we're doing it on demand when we want to, and that can be scattered throughout our program in a lot of different places. Let's take a look now at how that works. Let's take a look at this real simple program right here. And I don't do much. My program starts off by defining a function. I call it exp, which is short for, in my case, exponent. We haven't talked about how to do exponent calculations in Python, so I'm going to make a function that does it and prints the value for us. And I've done that right here. So I've defined exp, and then below that I've got my questions. What do you want the base to be? What do you want the exponent to be? And then I call the function. So two different things is happening here. I define the function up top, I call the function down below. I only need to define the function once. I can call it multiple times. Let's see this in action first. Let's see it run. So there, it wants to know what the base value is. I'll say 10 and my exponent 4. So 10 to the 4th is 10,000. You're welcome to go check my math if you'd like. So this called that function after I input my two values, and it multiplied the two numbers together that I put. And again, I can call this function many times over if I want. I could copy this and let's just say, let's call it 4 times right in a row. When I run it this time, I'll do the same thing. I'll say 10 to 10. You can see that it prints it out 4 times because it went and it ran that function. It executed it 4 times, printing the value every time. So let's take a little bit of a closer look inside of what went on here. For starters, I defined my function just like I said I was going to. The keyword def, D-E-F, that tells me that I'm starting a function. And then exp, that's the name of my function. That's the identifier that I'm going to use later in my code in order to call this function. Open paren and close paren, those indicate where my parameters are going to go. And then here I've defined two parameters, x and y. Those are positional parameters. So the first parameter is called x, and the second parameter is called y. Now, what's important here is that those are the names, x and y, that I'm going to refer to the parameters as inside of my function code itself, inside of my definition. So here's the little indented part. I create a new variable called z, and I say that's equal to x, in this case, multiple, y. So that's how I perform an exponent calculation in Python. That's doing the work for me. And then I print that resultant value. I print z, but that's really important. X and y are called x and y only inside of this indented code right here. That's the scope of those variables. We'll come back to scope a little bit later. So down here, when I call my function, I actually get two different variable names. I got one called base and one called exponent, and that's what I pass into my function call, base and exponent. I don't reference base and exponent up here in my function. It doesn't know about those variables. They don't exist yet inside of that function. And down here, I can't reference x and y because this part of my code doesn't know about x and y. So that's a little bit something to keep in mind. The other real important thing here is to note that my function definition went first, but it didn't do anything. It basically took that code and it set it aside for use later. So it stuck it off to the side there. And then the first piece of my code that's actually run, that actually executes, is line 7 here, base equals input, right? That's the first thing that happens. So I defined this function, it set it off to the side, and then I called it down below. And it's important to get that function defined up top. Check out if I do this. I'll just cut it and move it down below here, and I'll go back to just one call. We don't need to see the result 4 times. So if I save this, what's going to happen here? Well, we're going to have a real problem. First it asks me for the base value. I'll say 10. The exponent value, I'll make it 10 to the third. And I get an error. I get name exp is not defined. So what's happened? Well, Python, my program, doesn't know about the exp function yet. I defined it down here. So when I got to line 7 right here, there was no function to be called. So you got to make sure that your functions are identified or defined up above before you use them. And one of the best ways to do that, one of the most common ways to do that, is to actually save your functions, store them in a separate file that you import at the top of your main program. So I'm going to come here, and I'm actually going to pull my definition right out of this piece of code. I'm going to create a new file, and all that's going to do is define my function. I'll save it in here. I'm going to call it ben.py. It's in the same folder. It's in the same place as my main computer program, def1.py. So now all I need to do then is up here is say import ben. I don't need to include the .py. It knows that to look for a file named ben.py inside of the same folder, and that's going to cause that function to be imported into this code. So this does a couple of things. A, this makes sure that my functions are defined before I'm using them. I don't have to worry about defining them down below. It cleans up my main code a little bit, right? As long as I give my functions descriptive names, I can look at this and figure out maybe what's going on. I don't have to have my view clogged up by the exp function definition. If I want to see it, I'll just go over to the library and look up and see how it's defined. But otherwise, I've got it right here. So I'll save this, give it a run, and there it goes, 10, 8. Uh-oh, it's still not defined. What the heck? I've imported it. Well, here's a different little thing that I forgot to do. Now that I've imported it, I need to reference it by that name ben that I imported it as. So I actually need to say ben.exp. So just like we saw function calls on some other objects, this function call is now a part of ben. So I have to call ben.exp, and then I can run my code. Let's come over here one more time. 10 to the 6th is whatever that is, million, I think. So there you have it. You can store your functions inside of separate files, clean up your view, clean up your function calls, and you can actually create libraries of functions inside of a single file. I can have more than just .exp inside of my ben.py. Check this out. Here I've added 2 more function definitions to ben.py. So I'm turning ben.py into a full-fledged library. It's got a whole bunch of functions that I may or may not want to use throughout my program. I've still got my exp function up here. Now I've got one I've called print fib, and all that's going to do is calculate my Fibonacci series, and it's going to print it off for me. I'm calling the print function inside of my print fib function. I've also got another function down here called calcfib. And notice I can do cool things. I'm using a while loop inside of my function. That's going to work just like any other while loop. It's going to execute through. So my code is really just procedural code that I've shuffled off into this function definition. I'm also doing a return result, and this is how you get a value back out of your function. And I'll show you how I use them now so you can see how that works. Let's come over here, and let's do ben.fib. Remember, we have to call ben.print fib, and we will print the Fibonacci sequence up to 23. Save that, give it a run. That doesn't matter, and then it prints my 10,000. I did 10 to the 4th, and then there's my Fibonacci sequence printed up to 23. But if I didn't want it to print right out, if I just wanted to calculate the results, then I could do this. I could say, you know what? Fib series equals ben.calcfib. Remember, that's the other function name that I have. Printfib printed the Fibonacci series. Calcfib is going to calculate it for me. And notice it's case sensitive, so I have capital F's there. I got to make sure I use capital F's in my function calls. And I'm going to calc the fib up to 23. And then down here I can do print fib series. Again, save it. I'll go ahead and run this one more time. 10, 4, and there you go. Now it printed the series up to 23 because I called the print fib function first, and then I calculated it and printed my own calculation. That result, of course, if you noticed, was being passed inside of a list variable. So I got a list type variable out of my function. I printed it off on the screen, and I got my Fibonacci sequence listed. Pretty cool, right? Lastly, I want to finish up real quick and talk about variable scope and passing variables by value. A couple of things that I mentioned earlier in this nugget. So I've defined one more function inside of my ben.py library here, and that's byValExample. So it's just a function that's going to show off how a value gets passed in by value, or how a parameter gets passed in by value. And what I'm doing is I'm taking in one parameter called x, but then I'm immediately assigning a value to x. So it doesn't matter what the user passes in for that parameter. I'm setting x equal to the string, this value is overridden, and I'm printing it out. That's all my function is going to do. It's going to change the value of x and then print it to the screen. If I look back here at my code, you can see that what I'm doing is I'm giving x in my own code, in my containing program, a starting value. I'm creating a variable called x. I'm passing that in. So my byValExample is going to change the value of what I pass in, print it off, and then I'm printing x myself. And the question is, what's going to happen the second time? What's going to print out the second time? Well, it's easiest just to take a look and see it in action. You can see I get two strings printed out. The first one is from my byValExample, and it says this value is overridden, right? That's what we have right here. But below that, we printed out x in my containing program, and it says this is my starting value. So what happened here? Well, what happened is we passed in this parameter into byValExample by value. When I said x right here on my code, in between my parens, what I actually told Python is I said, hey, take the value of this variable and pass that into the function, and the function stored that in its own variable called x. It overrode it and it printed that, but that's its own variable. It only got the value from my containing program, and it printed that thing inside of its own variable. Out here, my variable never changed. I had my own variable out here in my containing program. Even though they're named the same thing, they have no relation to one another. So that means when the function was called and x value was changed, it did not change in the containing program. It only changed inside of the function. And that's something that we call variable scope. This variable, this x here, has a scope inside of my main program. That's where it exists. That's where it's defined. But inside of the function definition, there's a different variable called x, and that is its scope only inside of this function. I can't reference this version of the x variable outside of this function, and I can't reference this x variable inside of that function. So hopefully it makes sense. You understand how your variables have scope. They live within certain function definitions. That becomes more important when you get into more object-oriented concepts and you're building more larger, complex programs that use a lot of variables and have a lot of different variable scope. And that concludes the nugget on functions and function definitions inside of the Python programming language. To recap, we took a look at how you can call functions. Specifically, we talked about the internal built-in functions that Python exposes, things like print or input. How you define the name, you use the open parens. You always have to have those open parens, and you put your parameters that you want to pass to the function inside of those parentheses. We also talked about how you use the equal sign to assign the result of the function to a variable if the function actually returns a result. Then we talked about how we can define our own functions. We showed how to use the def statement to create a function that we can then use throughout our program, our own custom functions. And lastly, we took a look at how we can organize those functions into external files to clean up our code and how we can return our own values from those functions, as well as we talked about variable scope, understanding that variables that are defined by the function or inside of the function only exist and only live inside of that function, not inside of our larger containing program. I hope this has been informative for you. I'd like to thank you for viewing.